Deepakumaar from BCBUZZ Technology, and I'm a cybersecurity analyst at BCBUZZ Technologies Private Limited. These were my social media profiles: a LinkedIn profile and my profile in cyberexperts.org. And next, today we are gonna learn about networking fundamentals. And the agenda were introduction to networking, how network works, network topology, IP addressing, including IPv4 and v6, and network devices, protocol and ports, subnetting, OSI model, key takeaway, and Q&A. Now, introduction to networking. Networking is the connection of multiple devices to share data and resources. It is efficient for communicating between the devices, and it supports services like email, messaging, file sharing, etc. It includes the devices which are all connected through the internet, such as computers, mobile servers, PCs, and so on. Now, how the internet works? How the internet works? Since computer does not understand names like google.com, facebook.com, amazon.com, and so on, the request goes to the DNS server, which converts the domain name into an IP address. Once the IP address is found, the data is broken into smaller pieces called packets. These packets travel through multiple networks using routers. Each router helps in finding the best path to reach the destination server. When the packets reach the server processes request and send back to required data, such as web page or any request we have requested. Finally, all the packets are reassembled on the user's device, and the web page is displayed in the browser. So, in simple terms, the network works by sending data in smaller packets from one device to another device through different networks. And there were two two methods used to send the data. One is used using HTTP. In HTTP, the data can be intercepted by the attacker, which is the data is sent without any encryption as a plain text. In HTTPS, the data is secured and sent in an encrypted format. And next, network topologies. Network topologies. Network topology refers to how devices are arranged and connected in a network. It defines the structure of the network and how data flows between the devices. There are different types of network topology, each with its own design and use cases, such as bus topology, star topology, ring topology, mesh topology, tree topology, and hybrid topology. In bus topology, all the devices are connected through a single central cable. In a simple, it is simple and easy to implement. If the main, but the only solution, but the only problem is if the main cable fails, the entire network goes down. In star topology, all the devices are connected to a central device like a switch or hub, which is easy to manage, and failure of one device does not affect any other devices in the network. But if the central device fails, the whole network stops. And next, the ring topology. In ring topology, each device is connected in a circular form. Data travels in one direction around the ring in an entire network. If one device fails, it can affect the entire network. And next is mesh topology. In mesh topology, all the devices are connected through each other, and the communication can be done between the one device to any other devices connected through connected in the network. And next is tree topology. In tree topology, it's like a hierarchical structure. The main device is connected through the sub devices, and the sub devices are connected through the another sub devices, which can be accessed through the main devices. And next is hybrid topology. In hybrid topology, the all the network topologies are connected using various topologies like bus topology, star topology, ring, mesh, and tree. In this the network can be simplified and managed easily due to the different types of networks connected. And next is about IP address. IP address is Internet Protocol address. It is a unique identifier for a device on a network, which is used to locate and communicate with devices. Consists of network and host ID, and allowing routers to direct packets correctly. Why IP address is needed? IP address is needed because identifying source and destination of a data. It enables routing of packet across the networks, and it ensures the devices that can communicate and find each other in the network, in the internet. Next, IP addresses version. There are two types of IP addresses version. First is Internet Protocol version 4 and the another is Internet Protocol version 6. Firstly, the IPv4. It is a 32-bit address written in decimal format. Example 192.168.1.1. In this, the each is classified each is divided as 8 octet. 192 is for 8 octet, 168 is assigned as 8 octet, and one is 8 octet, and another one is 8 octet. And it's in IP address, it supports about 4.3 billion addresses, unique addresses. And the next is IPv6. It is 128-bit address written in hexadecimal format, such as 201 uh, colon DB8 colon 1, which is alpha numerical value. It uses anycast and multicast, and it does not support broadcast. And IPv4 classes and ranges. It is classified based on the first octet of the IP address, helps in efficient allocation of IP addresses. Each class is designed for different network stages to separate large, medium, and small networks. The IPv4 are divided into several classes such as Class A, Class B, Class C, and Class D, and Class E based on network size and usage. Class A. In Class A, Class A is used for large networks and multinational companies. Supports up to 16 million hosts per network. And Class A IP range is 1.0.0.0 to 126.255.255.255. And the default subnet mask is 255.0.0.0. And the private IP in the Class A is 10.0.0.0 to 10.255.255.255. In Class A, the another is loopback address. One loopback address is for testing and connecting to the local host address for the checking and performance of our networks. 127.0.0.0 slash 8 is the subnet of the local host address, is the network range. And the local host address is mainly used as 127.0.0.1. And next, in Class B, it is used for medium-sized network. It supports up to 65,534 hosts per network, and its range is 128.0.0.0 to 191.255.255.255, and the default subnet mask is 255.255.0.0, and the private IP range in Class B is 172.116.0.0 to 172.31.255.255. And the next, Class C. Class C is for a smaller network or small businesses, which is like a home network or small network devices or limited number of devices located. It supports up to 254 hosts per network. The range of a Class C IP is 192.0.0.0 to 223.255.255.255, and the default subnet mask of Class E is 255.255.255.0, and the private IP range in Class C is 192.168.0.0 to 192.168.255.255. And next is Class D. Class D is reserved for multicast devices, sends data to a group of devices, not a single device, which is used for mainly a broadcasting. And the range of a Class D is 224.0.0.0 to 239.255.255.255. And the next one is Class E. The Class E IP address is reserved for research and experimental purposes, which is used for testing and future use. The range of a Class E is 240.0.0.0 to 255.255.255.255. And next is about IPv6. IPv6 is a 126-bit IP address, which is written in hexadecimal formats, and it is divided into 8 groups, 16 bits each, and separated by a colons. Consecutive zeros can be replaced with double colon. Example: to 2001 colon 0DB8 colon 85A3 colon 0000 colon 0000 colon 8A2E colon 0370 colon 7334. This is an example of an IPv6 address which is hexadecimal, including the alphabets and numericals. In this, the 000, the repeating zeros can be replaced with double colons. And why IPv6 is used? Because IPv4 has limited addresses, where the address has exhausted, so that we have moved to IPv4 to the IPv6. IPv6 provides large address space, and it also supports modern networks like IoT and the cloud. IPv6 address type. IPv6 address types were unicast, multicast, and anycast, where unicast is one-to-one address, and multicast is for one-to-many, and anycast is for one to the nearest devices. Where the special addresses were colon colon 1, which is used as a loopback address or a localhost address, like like the localhost address on IPv4 127.0.0.1. The unspecified addresses can be mentioned as colon colon. And the next, network devices. The network devices is mainly as routers, switches, hub, switches, hub, and a bridge. Routers. Router connects different networks. Router connects different networks, your home network to the internet. It uses IP address to forward data, which finds the easier route and the simplest form to transform a data from one device to the another device. And next is switch. Switch connects multiple devices within the same network, such as LAN. It uses MAC address to send data to the correct device, and it reduces network traffic by sending data only where it is needed. Unlike router, the switch sends the data which is sent to the devices which is allocated for. And next, hub. Hub is a broadcasting device which sends the data or broadcasts the data to all the connected devices. It connects multiple devices in a network which does not filter or manage traffic unless the bridge. The bridge is used to connect two or more network segments, filters traffic using MAC addresses, and it reduces unnecessary traffic between segments. Unlike the hub, it can filter the traffic and sends without using unnecessary traffic between the networks. And next, ports and protocols. A port is a logical endpoint used by applications to communicate. And there are the ports ranges were 0 to 65,535, and it works with the IP address, means IP plus ports is for communication. A protocol is a set of rules that define how data is transmitted over a network, which ensures the communication between the devices. There are several protocols, for example, HTTP, FTP, SMTP, which is used for the communication between the devices among the network. And these are the common protocols and port numbers used used severally. The protocol HTTP uses port 80, which is for web browsing, whereas HTTPS is also used for web browsing, which uses port number 443, and it sends the data or transmitted data as an encrypted text, unlike HTTP. In FTP, it's for file transferring, and the port number is 21. And SSH is for secure remote access, which uses the port 22. And telnet. Telnet is for remote login, which is insecure nowadays, and uses port number 23. And SMTP. SMTP is for sending mails, which uses a port number 25. And DNS. And DNS. DNS is for domain name resolution and uses port number 53. And DHCP. DHCP is a dynamic host configuration protocol which assigns the IP address to the devices dynamically, and it uses the port 67 or 68. And next is POP3. POP3 is for receiving emails, which is which uses port 110. And IMAP. IMAP is for email accessing and uses a port 143. And the next one is network monitoring, which is protocol SNMP and the port number 161. Next, subnetting. Subnetting is the process of dividing a large network into smaller networks. Like if in a class A network, if we have 1.0.0.1, it can be it can be divided into smaller networks for managing and maintaining the network devices among the network. It improves performance, security, and management. Defines which part of an IP address is the network and which is host, and why subnetting is required. Subnetting enhances security by isolating networks and improving the efficiency among the network devices. Efficient use of IP address because the unused IP address were assigned by the another devices on the network, and it improves the network performance and does not overload the network in IP addresses. And next, for example, a network address 192.161.1.0/24. Here the slash 24 means the first 24 bits are used for the network part from 32 bits, and the remaining 8 bits are for host. Network part 192.168.1. Something the number between the host was assigned, and the host part is the last number, which is identify the device from 0 to 255. To notice, all devices in the network must be have the same network part 192.168.1, and the remaining last bit is assigned by the is a host part which defines the devices connected. And next, network address range, the types. If we take an IP address of 192.168.1.0, it is a if we take an IP address of 192.168.1.0 as an it is a it which is a first IP address of an network. It is known as network address, and the host connected in this network is first host is 192.168.1.1, and the last host is 192.168.1.254. And the last IP address in this network is 192.168.1.255 is the broadcast address. And the devices were connected in between 192.168.1.1 and 192.168.1.254. These were the IPs allocated to the devices connected in this network. And OSI model. OSI model is a framework that explains how data travels from one computer to another over the network. It helps different devices communicate properly, which breaks down the communication process into similar steps. Data moves from top to bottom, which is center side, and, and bottom to top as a receiver side. These were the 7 layers of OSI models from application application, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Application layer. If a sender sends an message through the application layer, it sends through from the application layer. It accesses protocol used by application to communicate data to the end user. In presentation layer, it is it presents how the data is transmitted and how it is encrypted or in compression format. And in session layer, it manages the connections across the devices in the network, which defines the session should be managed in how long and how should be session opened and when it should be closed. In transport layer and transport layer transport layer is used for transmitting the data using the protocols such as UDP, which is user datagram protocol, and TCP, transmission control protocols, which is, in which the UDP is used as is a connection-less oriented protocol, which transmits data without any confirmation from the receiver side. In TCP, the request is firstly sent from receiver to sender, and the sender acknowledges to the receiver, and then the package will be shared between the devices. And in network layer, conducts routing between the different paths, determining the most efficient path, which is used to send the data packets from sender to the receiver in a easiest path to achieve the data loss or any data overhead in the networks. And in data link handles node to node data transfer between devices on the same network. And next one is physical layer. It converts the data into bits to carry it across physical network equipment. And next, and the key takeaways. Networking enables efficient communication and resource sharing. And OSI model provides a structured approach to data transmission, where the physical layer is for transmit raw data to a physical medium, and it defines signaling, bit timing, clock recovery, line coding, connector principles. IP addressing, ensuring unique identification of devices. In IP address, there are two versions. One is IPv4 version 4 and version 6. IPv4 uses 32-bit address, which can support up to 4.3 billion addresses. And the 4.3 billion addresses are exhausted and not available for the another upcoming devices in future. So that we are moving to the IPv6, which supports 128-bit address and written in hexadecimal formats such as alphanumerical format, and it uses anycast and multicast, not used for broadcasting. And next one is subnetting. Subnetting improves network performance and management. Whereas subnetting is improves the performance, security, and management, which defines the which part of IP address is the network and which is the host. It is mainly used for isolating from the network in the internet, for improving the security and the efficient use of IP address, improves the network performance. And next, protocols and ports define communication rules. The protocols such as HTTP, HTTPS, FTP are the certain set of rules which which is used in network for transferring data and secure browsing and remote logging and domain name resolution using the several port numbers from 0 to 65,000, where the port is a logical endpoint which is around 0 to 65,533. And the protocol is a set of rules which defines how data is transmitted over a network. Network devices control, forward, and secure data. Network devices. Network devices hub, bridge, router, and switch. Router. Router connects different devices such as home network to the internet. Uses IP addresses to forward data, which is which is assign the path for the data to travel through the network. And switch. Switch connects multiple devices within the same network, such as LAN, and it uses MAC address to send the data to the correct devices, and it reduces the traffic by sending the data only the device which is allocated for. For example, the print is sent to the printer, and the printer has the MAC address which is assigned. And the next, hub. Hub is used for broadcasting data to all the connected devices. It connects multiple devices in a network and does not filters any networks or any packets and sends to the all the devices in the network. And bridge. Bridge is used for connecting between two or more network segments. It filters using the MAC address, and it reduces the network traffic by filtering the networks. Understanding network is essential for IT, cybersecurity, and system design, where networking is most important, and we have to secure the network to prevent from the attackers. And there were the three main goals: confidentiality, integrity, and availability. Confidentiality means keeping data private, and integrity means data should not be alerted by the anyone or any unauthorized access. And availability ensures the accessible when needed and where needed. And there were firewalls, antivirus, anti-malware, encryption, decryption, and so on, which is used for securing the securing the devices from the network. This is our learning platform. Learn at BCBUZZ.io. Learn the free courses in this academy. And this is our BCBUZZ WhatsApp channel. You can join for the further updates or any queries in future. And the next session is about network securities, which is scheduled on Wednesday. For the further details, you can or contact through our WhatsApp channel, or you can see the updates on learn.bcbus.io. Okay, thank you.